Thank you. I am Robert Haas. I've been hacking on PostgreSQL since about 2008. I started working at EDB in 2010, and my current job title there is VP Chief Architect Database Servers. I'm very excited to be here today to tell you about a new feature that I developed for PostgreSQL 17, which is incremental backup. And let's see if I can use the slides. Okay. So the idea of incremental backup is that we want to make a backup of our database, but we don't want to have to copy the whole thing. Instead, we'd like to just copy the parts of the database that have changed since maybe the last time we made a backup or some previous backup that we made. So our goal is to make backups smaller than they otherwise would be, and as a result, to make the backup process faster. And there are some possible trade-offs there, mostly I think in terms of recovery time, which I'll mention a little bit later in the talk. A couple of things about this particular implementation of incremental backup. I focused here just on relation files. Typically relation files, which means your tables, your indexes, maybe your materialized views, account for most of the database size. If you are familiar with the layout of a PostgreSQL data directory, you know that there are other files in there and that sometimes those files can take up a significant amount of space. There are directories like PG subtrans and PG xxstatus and PG multi-exact. And in this implementation, we don't do anything incremental with any of that data. That data is always copied in full. On the positive side, this is a block level feature. So PostgreSQL typically stores relations, again, I mean tables and indexes, in files of up to 1 gigabyte in size. So if you had a file level incremental backup feature, that would mean that you could insert one row into the table and then have to copy an entire gigabyte of data because that 1 gigabyte file had changed. This is a block level feature, so we're going to make a separate decision for each 8 kilobyte block within that 1 gigabyte file. And so that will hopefully, in most cases, produce smaller backups, although how much smaller depends a lot on what your modification pattern is. The reason I started working on developing this feature is because I've encountered a bunch of cases in my work at EDB where people actually got into a situation where their database was so large that it took more than one day to back it up. That's not great because you would really like to be able to do daily backups. And of course, if it takes more than a day to complete the backup, then you can't do that. The I/O cost of backing up large databases is really the dominant cost. It doesn't take a lot of CPU cycles to copy a terabyte of data or 10 terabytes of data or however much you have, but it does use a tremendous amount of I/O, read I/O, write I/O, maybe network I/O. And people are solving that problems in various ways already. It's not like you can't use PostgreSQL with a big database unless you have this feature. One pretty popular solution is to use some kind of specialized hardware that has volume snapshot capabilities. Or maybe you are using PostgreSQL through a cloud provider who tells you that they will take care of all of your backup needs, and so you don't have to worry about it. But I really felt that it would be good for PostgreSQL itself to have a solution to this problem that did not require special hardware and that would just run everywhere. And even that already does exist. In fact, several different versions of it exist because there are quite a number of PostgreSQL backup tools out there on the internet. Some are better than others, but nearly every PostgreSQL company has one at this point, I think. And many of those have implemented some form of support for incremental backup. But all of that logic is outside of core. All of that logic is specific to the individual tool. So if you switch from one tool to another, you're going to get a different set of features and maybe also a different set of bugs. So I thought that it would be good if we had something in PostgreSQL itself that hopefully we can grow toward having everybody have some level of endorsement for that feature. We'll see how that goes. This is open source, so on the one hand, that means that we are all hopefully collaborating with each other and working together toward a set of solutions that benefit everybody. But on the other hand, it also means that everybody can do what they want. So maybe people won't use this and they'll use something else, and that's also fine. I do feel obliged to put a bit of a disclaimer in here. This is a scary feature. When I implemented parallel query, that was also a scary feature. But if you think about it, the worst thing parallel query can do is give you the wrong answer to your query, most likely. Maybe it can crash your database. This feature here can actually lose your data. And in fact, it's pretty likely that if there are bugs in this feature, which there probably are, they're likely to be data loss bugs. So this has been tested. I've tried to make it good. I hope you use it and derive some benefit from it. But don't make the mistake of assuming that there are no bugs. All code has bugs, and my code is not an exception. So let me show you how you can take an incremental backup. There is one piece of mandatory configuration if you want to use this feature. You need to go into postgresql.conf and set the summarize wall parameter, which is a new parameter, to on, or you can use the alter system command to do the same thing. Either way, you will then need to reload the configuration or restart the server in order for the new setting to take effect. Now, once you've done that, the second bullet point on the slide here shows how we can take a full backup, which is not new, but we have to do it before we can take any incremental backups. I was just doing all of these examples for testing purposes, so I used the -C fast option here, which I highly recommend for testing, because otherwise you end up waiting for a long time. But I might not recommend for production, because it can generate a load spike on your server, which may not be what you want on your production machine. In the third bullet point on this slide, we kind of get to the meat. We get to the real feature. Here I'm taking an incremental backup. And that backup is going to go into a new directory called Monday. The -- incremental flag indicates that this will be an incremental backup. And then I need to pass the path name to a backup manifest from some previous backup. In this case, the backup that's stored in the Sunday directory. So I'm saying that in the Monday directory, I'm going to end up with an incremental backup that is relative to Sunday's backup. Whatever has changed since Sunday's backup needs to be included in Monday's backup, but the unchanged portions don't. And then the last bullet point on the slide, we roll it forward another day, or maybe 5 minutes if you're just testing this out on your own machine. But we roll it forward another day, and we say on Tuesday we'd like to take another backup. And we can make that relative either to Sunday's backup or to Monday's backup, just based on which backup manifest we pass. We don't need to have the entire previous backup available, although in this example we do. We just need to have that one backup manifest file available, and we can take an incremental backup. So if on Tuesday we take a backup relative to Monday's backup rather than Sunday's backup, that is going to hopefully make Tuesday's backup smaller, right? Because instead of Tuesday's backup containing everything that changed since Sunday, it will only contain the things that have changed since Monday, which presumably is less. So the second command there, if we use that one, would hopefully create a smaller backup for us. But it does mean, if we do it that way, that we'll need all 3 backups to be available when we want to restore, because our data will be spread out across 3 different backup directories. Hopefully that makes sense to everyone. I've given this talk a few times now, and I've discovered that this is a good point in the talk to just see if anybody has a question, because if what is on this slide doesn't make sense to you, the rest of the talk is going to be very rough. So please feel free to ask something now if you have a question. Can I get a question there? No? Okay. Everybody good? Okay, I see a few heads nodding. There is one other configuration parameter that you can set that is specific to this feature, and that is called wall summary keep time. And the way you want to think about this parameter is to think about the question, when I take an incremental backup, how far back in time was the previous backup to which this incremental backup is going to be relative? So in the example we just did, it would be a day, right? Because we were taking an incremental backup on Monday and then another incremental backup on Tuesday, so the elapsed time was 1 day. So to make that example work, we would want wall summary keep time to be more than 1 day. I would say comfortably more than 1 day, because you don't want your backups to start failing if something gets delayed or whatever. We set the default for this to 10 days, which I think is a lot, because that means you could take an incremental backup relative to a full backup that was a whole week ago. You may not want to go further back in time than that, right? Like you could, hypothetically, take a backup now, and then in a month, take an incremental backup relative to today. And then if you wanted to do that, the default value of this parameter wouldn't be large enough for you, because a month is more than 10 days. So you would need to raise the value of this parameter. But that's probably not a good backup strategy. I wouldn't recommend taking a backup only once a month. And if you do, you might be a little safer if you made it a full backup rather than an incremental. You could also lower this parameter, but it doesn't buy you very much, because the wall summary files, as we'll discuss a little bit more later, are actually quite small, so you don't save much by reducing this. I don't advise anybody to run PG-based backup in any form by hand on their production system as their primary way of doing backups. You should really use a backup tool. I'm not here to tell you what backup tool you should use. There are a lot of them. If you want to use this feature, you will need a backup tool that supports this feature. I know that some of my EDB colleagues have added that support to Barman. So if you're interested in using this feature, you might want to check that out. But hopefully there are other tools that either have added support or will add support. I just don't know which ones they are. But I find that when people try to write backup scripts themselves, they often miss things like error checks or important steps that are really required. So I'm showing very manual examples in this talk, just to give you an example of how the feature works at a base level. But you do want to wrap some tooling around that, because otherwise, for example, you won't have any management of your backup retention. You won't have a backup catalog. You'll have to figure all of that out yourself. And that's probably not where you want to be. So let's talk about how it works. What are the problems that needed to be solved in order to make this feature happen? I think some of you will have guessed that the core challenge here is knowing which data has changed and which data has not changed. If we're going to do an incremental backup, and the idea is that we only want to copy the modified data, we need a way of knowing which data has been modified. And we have a few requirements for whatever that method is that's going to tell us how the data was modified. First of all, it needs to be accurate. If we make a mistake and we think that some data is not modified when it actually was, that's a data loss bug. Because if we think the data wasn't modified when it actually was, we won't copy it, we won't include it in the incremental backup, and it will be gone if we do a restore. Probably the database will end up being inconsistent in a case like that, and you'll just have a corrupted database. A mistake in the other direction is not quite as critical, but it's still not good. If something wasn't actually modified, but we think it was, then we will include it in the backup when we didn't really need to. That is not a data loss bug. It just makes the system less efficient. So we don't really want that kind of behavior either. A second requirement here, which is also very important, is that we have to be able to determine what data has changed and what data has not changed efficiently. We need to be able to make that determination quickly. If we have to grovel through many gigabytes or even terabytes of data to determine what to include in an incremental backup and what not to include, then it's not going to be fast. And that is not where we want to be. So we need something that's pretty cheap. I also wanted a system that was easy to implement, and partly that's for my benefit, because the less there is to implement, the more likely I am to finish the feature. But it's also for your benefit as users, because the more new code I have to write, the more bugs I'm going to introduce, most likely, all things being equal. So relying on existing infrastructure is an important part of protecting users by not exposing them to more coding errors than necessary. And finally, I wanted something that wasn't going to rely on OS features, especially any OS features that might be different on different operating systems. File timestamps are a case here that is like that. They don't behave on Windows the same way they behave on Linux. They may not even behave the same way on all Linux file systems. I didn't want to depend on stuff like that. I wanted to have something that was entirely internal to PostgreSQL. I thought that would make sure that it was reliable everywhere, worked the same way for everyone, and was easier for me to debug if anything goes wrong. And in thinking about those requirements, I realized that the write-ahead log had a lot of things to recommend it. First of all, the write-ahead log already contains all of the information that we need about which database blocks have been modified during any particular window of time that we might care about. And it's already used for many other very critical purposes. For example, every time your database crashes, we use the write-ahead log to restore consistency. Every standby is powered by the write-ahead log. Logical replicas or logical decoding are powered by the write-ahead log. We use the write-ahead log for point-in-time recovery. And we have existing debugging tools like pgwalldump and pgwallinspect so that we can see what's happening in the write-ahead log and understand what may have gone wrong in the case of any problem. So it's a really good tool. The write-ahead log is something that PostgreSQL has been working on improving for, 20 years probably now. 25 years? A long time. And I think it's generally very robust. But it does have one big disadvantage for our purposes here, which is that it's very big. Think about how much write-ahead log data could be generated between a full backup and an incremental backup. I think you could plausibly have scenarios where that's a terabyte of write-ahead log data, and we certainly don't want to read that much data at the time someone asks for an incremental backup. We probably couldn't even read all of that data at the time that somebody asks for an incremental backup, because it's probably not all stored on the server where the backup is being taken. Some of it may have been archived or deleted. But we can use the write-ahead log indirectly. And the way that I did that is I added a new wall summarizer process, which reads the write-ahead log as it's generated, and it produces wall summary files that contain only the information that is 100% required for incremental backup. The actual write-ahead log tells us how each block was changed. We don't care about that. It tells us how many times each block was changed. We don't care about that either. It tells us the order in which different blocks were changed relative to each other. We also don't care. We need a little bit of information about when blocks were changed, but not very much. We just need to know whether a certain block was changed before or after a certain backup. So we can also throw away most of the information about when things happened. And by throwing away all of this information, we reduce the volume of data very, very massively. The file format itself has also been optimized as much as my colleague Dilip Kumar and I were able to figure out how to do. And I think it's a pretty compact file format. I've seen these files typically being, tens of kilobytes in size. Maybe you can get to hundreds of kilobytes with the right workload. It's quite difficult to get these files up into the megabyte range, and even if you can, that's still not very big on modern hardware. So we take our great big write-ahead log that contains the information we need. We turn it into our little tiny wall summary files, which still contain the information we need, but not all of the other stuff that we don't care about for this purpose. And then we should be in good shape, mostly. There is also a new debugging tool that can dump the information from these files if we need to do that for some reason. We don't quite get all of the information that we need to power this feature from the write-ahead log itself. There are a couple of gaps. And we fill in those gaps using the backup manifest, which you kind of already saw in the examples that I showed earlier in the talk, where we ran PG-based backup with the -- incremental option, and then as an argument to that option, we passed the path to some previous backup manifest. The biggest thing that the backup manifest tells us is when the previous backup happened. But not in terms of wall clock time, because we don't care about wall clock time. What we care about is the position in the write-ahead log. We have, because we're running with summarize wall equals on, a series of wall summary files, each of which tells us what changed during some range of write-ahead log positions. The term we use to refer to a write-ahead log position is an LSN, or log sequence number. But we need to know, out of all of those wall summary files that we have, which ones are relevant to the incremental backup that we're trying to take right now. So if it's Tuesday and we're taking an incremental backup relative to Monday's backup, we need to look at all of the wall summary files, beginning with the start of Monday's backup and going up to the start of the current backup. And we need to look at the blocks that those files say were changed and back all that stuff up. And the backup manifest tells us when, in terms of LSNs, write-ahead log positions, it tells us when that previous backup happened so that we know which wall summary files are relevant. There's one other bit of information that we also need from the backup manifest, and that information is used to distinguish between two corner cases. Imagine that we have a file that's in the data directory now, and we're in the process of doing an incremental backup, and we come to that file. And we check all of our wall summaries, and they say, there have been no changes to that file. What do we do? There are two possibilities, actually. I think the more obvious possibility is the file hasn't been changed in a long time. It hasn't been changed since before our reference backup, and it's just been sitting there on disk with no modifications. In that case, we don't need to store any data blocks. But it's also possible that it could be a brand new file that was created after the current backup began. Because unlike some other systems, PostgreSQL does not pause writes to the data directory while a backup is in progress. So it's possible that we looked at all the wall summary files, made all of our plans, and then started looking through the data directory. And as we were doing that, poof, a new file showed up. And in that case, we do want to include the file in the backup. So fortunately for us, the backup manifest contains exactly the information that we need in order to figure out what to do, because it includes a list of the files that were in the previous backup. So if the file we're currently looking at was there as of the time of the previous backup, we know this is an old file that has not changed in a long time. If it wasn't in that previous backup, we know it must be a brand new file that just got created. It can't be anything in the middle, because if it were, the wall summary files would tell us, hey, that's just been created, or that's had some blocks modified, or whatever the case might be. So now let's look at how we restore an incremental backup. We'll go back to the example that we were using before, 3 backups, a full followed by 2 incrementals, the second incremental depending on the first one. Now let's think about what the state is on disk after creating these 3 backups. If we want to restore the Tuesday backup, where is our data? Well, everything that changed between Monday and Tuesday is in the Tuesday backup, of course. Everything that changed between Sunday and Monday is in the Monday backup, and all the other data that we need is in the Sunday backup. So what we need is a data directory that we can use to run Postgres. And none of the directories that we have are that. We need to pull the correct data from these 3 different backup directories that we have and combine it into a data directory. So there's a new tool in 17 to do exactly that. It's called PG Combine Backup. And we need to run that tool here. I debated what order of arguments would be least confusing for PG Combine Backup, and I decided oldest to newest seemed least confusing. But it's still maybe a little bit confusing, because if you look at that command line there, the backup that we're trying to restore is the Tuesday backup. We're not trying to restore Sunday's backup in this example. We're trying to restore Tuesday's backup. So you might expect that Tuesday would be mentioned first, or that it would have some bright lights around it, or it would look special somehow. Just keep in mind that if you're restoring an incremental backup this way, you need to mention the backups in chronological order, starting with the first and going up to the last. But it's the last backup you're trying to actually restore. And then we specify an output directory using -o, which in this case I just called Tuesday full. Now, when you run PG Combine Backup, what you get is a synthetic full backup. And that means recovery is still required, just as it is for any Postgres full backup. So all of the things that you need to do, or all of the valid configurations that are possible for a regular full backup, you need to do all that same stuff here. Maybe you need to create recovery.signal or standby.signal. Maybe you need to set primary coninfo. Maybe you need to set restore command. Maybe you need to put some wall files in PG wall. This, again, is a good reason to use a backup tool, because it can orchestrate this work for you instead of you figuring it out yourself. But I just want to emphasize that running PG Combine Backup is an extra step that happens before the normal restore procedure, rather than a replacement for anything. Now, we could, if we, for some reason, wanted to, restore even more incrementally. So looking at our same example, what I did a couple slides back was to combine Sunday, Monday, Tuesday, and make a new data directory Tuesday full. But I could also, if I wanted to for some reason, combine Sunday and Monday to produce a Monday full, and then combine Monday full with Tuesday to produce a Tuesday full. And this is actually, if I do it exactly this way, probably pretty useless, actually actively harmful, because I just doubled the amount of I/O that I'm going to do. Instead of writing out one new data directory, I've written out two new data directories, which is approximately twice as expensive. In general, the amount of I/O that PG combined backup is going to do is roughly proportional to the size of the output directory. It will skip reading data from the input directories that it doesn't need to write out to the output directory, except for a little bit of metadata. But it's a lot of I/O to generate one of these directories, so doing it in 2 steps is probably not the greatest plan. But it could make sense in some scenarios, particularly when those 2 PG combined backup steps happen at different times. So like if you start taking incremental backups every day, these chains are quite rapidly going to get pretty long. You know, if you take a full backup on Sunday and then take incremental backups on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, you're going to need to have all of those backups available if you want to do a restore of Saturday's backup, and that's already quite a lot. You can't do it. It will work, you know. But you might want to shorten that chain of backups at some stage. So what you could do is say, well, I don't care about anything before Wednesday anymore. I know Wednesday is all right. So let me just combine Sunday, Monday, Tuesday, Wednesday into a Wednesday full, remove all of the input directories, move the Wednesday full directory to Wednesday, and now instead of Sunday being the full backup that starts the chain, Wednesday is the full backup that starts the chain. So now if I do end up needing to restore Saturday's backup at some later time, I only have to include 4 backups in my chain rather than all 7. That is potentially quite advantageous. In fact, if you were really brave and you trusted that this feature was not ever going to eat your data under any circumstances, you could stop taking full backups altogether. You could just take new incremental backups, and then you could use the technique that I had on the previous slide to keep the backup chains short. I wouldn't really recommend this in the short term because this is a brand new feature, and like I say, it might have bugs. But hopefully we'll get to a point where we're confident that we've found whatever bugs are there. And then I think this technique in the long term has a tremendous amount of potential. Because many people these days have very large databases and very low turnover rates. Not everyone has that pattern, of course, but if your turnover rate on a daily basis is 10%, and your database backup would run for 20 hours if it were a full backup, that means you can do an incremental backup in 2 hours. And if you never had to do one of those 20-hour backups again, and you just had to do the 2-hour backups, then you might think that this technique is manageable and implementable. Whereas if you were going to have to keep taking those very long, painful 20-hour backups from time to time, you might decide that this whole way of taking backups was not going to work for you, or maybe even that Postgres was not going to work for you. So I'm very excited by the potential here. Try it out, but maybe not on your most critical data yet. So where do we go from here? There are a number of things that we could add to this that would make it better. Right now, PG Combined Backup can only work on plain format backups, which means if you have a tar format backup, you're going to have to untar it yourself and then run PG Combined Backup on the extracted directory, which is going to take more time and more storage space. I think in general, one of the big disadvantages of this feature as we have it today is that when you wanted to restore, you need to do a lot of staging. You're going to need to stage all of the backups that you want to restore from on the server where you're doing the restore or somewhere else, so that you can run PG combined backup and have all of those directories available. And that's going to be sometimes kind of painful just because backups are big and they take a long time to move around and a lot of space to store. A couple other things that might help here, PG combined backup -- link. If you're familiar with the idea of the link option in PG upgrade, this would be a similar kind of thing. The idea is that you're okay with destructive modifications of the input directories because you know that the input directories are just temporary. And so instead of copying files to the output directory, we would just hard link files to the output directory in cases where the whole file that was being produced as output came from the same input directory. That wouldn't work in cases where we have to mix blocks together from different sources, but any files that were being copied in their entirety, we could skip the copying and just hard link them if we knew that you didn't care about spoiling the source. It would be useful also, I think, to be able to combine multiple incremental backups into a consolidated incremental. You can't do that right now. You always have to start PG combined backup with a full backup. And PG combined backup can only read from local storage. It can't read from the cloud. And then there are various other kinds of things here. I don't know how much of it is going to be required, but maybe we'll find we need to do some performance work on some part of this solution. Maybe we'll need to fix bugs. I don't know yet. This is still quite new. Before I close, I just want to mention that I've started up a hacker mentoring program. If you're interested in hacking on PostgreSQL and working on features like this or other kinds of features that you may be interested in, we do have a little program for that. We have monthly Zoom calls where we talk about topics that are of interest to potential hackers. We have a Discord. Please join us if you're interested in any of that or ask me about it. Thank you all for coming. Great to have you here. Hope this was interesting, and I'm happy to take a few questions in the time we have remaining, if anyone has any questions.
Yeah, I will take the idea.
He has a question. I'm glad someone has a question. Oh.
Okay, can you hear me? Yeah. Okay, thank you. Okay, in the previous slides, in the examples, it was shown that one incremental backup was taken per day. Is it possible to do more incremental backups on the same day?
Absolutely. So those examples, I tried to make it clear. I just gave the directories the names Sunday, Monday, and Tuesday, right? But you can run the command as often as you want. In fact, I ran those three commands one right after the other because I was just doing a demo for testing purposes. One of the things that's been mentioned to me is that some people might want to use this feature by increasing their rate of taking backups. So one thing you could do is replace some of your current fulls with incrementals, but another thing you could do is add more incrementals between the fulls you're already taking, which might actually be useful in speeding up restores because you could sort of fast forward to a particular point in time and just run recovery from there. So yes, absolutely can do it as often as you want. Anybody else? No? Oh, over there.
When you create a backup, you refer to previous one.
when you create an incremental backup. So if you do PG combine, why do you have to list all the list of the previous backups? Does the backup know the information, what it is based on?
It does not. Okay, so yeah, so this again comes back to the importance of tooling. The PG combined backup is able to validate that the backups that you give it are the right ones, but it has no way of finding them. Like, it doesn't have any idea where you've stored any of that data. So a full-blown backup tool built on top of this would presumably know that. It would know this backup depends on this backup, and this one is stored here, and that one is stored there. But PG Combined Backup has no idea about any of that. You can move data or directories around to different machines or whatever you want to do. It doesn't care. It's not looking for anything other than what you give it on the command line. So that's why you have to tell it where things are.
Thank you.
Okay, thank you, everyone.